Welcome to the third and final video for section 5.2, and so far we have looked at horizontal asymptotes, we've looked at vertical asymptotes in reverse order, and now all that is left are the oblique asymptotes, or those asymptotes that are slanted. Some books do call them slant asymptotes as well. And like many of the other examples, we begin with what is the graph, and can we determine the asymptote from there, in particular an oblique asymptote. And if we look at number 14, we do have an oblique asymptote. It's that dashed line that is going slanted right there. And then basically what we need to do is we need to determine what is the equation of that line. Well, it should be pretty obvious that 0, 0 is one of the points on that particular line. And, you know, with a little bit of a straight edge of a paper or whatever, we can see that 5, 5 is also a point that's on that line. And so to find this slope, or the equation of this line, first thing we have to do is to find the slope. And that's 5 minus 0 over 5 minus 0, or 5 over 5, which equals 1. And then if we use the point 0, 0, that's very simple. It's y equals 1x plus the intercept, which is 0. So y equals x would be the oblique asymptote. Now, how do we know when we have an oblique asymptote? Well, this goes back to the degree of the numerator and degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then we know the asymptote is y equals 0. But if they are exactly equal, then we set y equals, and then we put the two leading terms over each other and then simplify it from there. Now, the next question becomes this. If the degree of the numerator is 1 more than the degree of the denominator, and 1 more and only 1 more, then we have an oblique asymptote, and we will actually get that, or we will see an example of that a little bit later. But if it's 2 or more bigger, then there's no asymptote at all. So we've hit all the possibilities. If the degree of the numerator is less than, then we have to, if it is less than, then it's y equals 0. If the degree of the numerator is equal to the degree of the denominator, you have to do that simplification. And if the degree of the numerator is 1 more than the degree of the denominator, then you have to do what is asked for in number 15. Number 15. We have x squared minus 7x plus 3 over x plus 9. Now, there's nothing to simplify here, so the degree of the numerator is 2, the degree of the denominator is 1, and the numerator is 1 more than the denominator. So what we have to do is we actually have to do the division here. We have to take x squared minus 7x plus 3 and divide by the x plus 9 and see what we get. Well, x goes into x squared x times. So we take x times x plus 9, that's x squared plus 9x. We do a subtraction. X squared minus x squared cancel each other out. Negative 7x minus 9x is negative 16x, and bring down the next thing. What do we have to multiply by x to get negative 16x? And that's negative 16. And realize once we get this, everything else that's left is just the remainder, and we really don't need to worry about the remainder. Once we get to a constant right here, in other words, no variables, and as long as we know that is the answer, then we can stop. Our final answer is y equals x minus 16. That is the oblique asymptote. Now once again, that only works if the degree of the numerator is 1 more than the degree of the denominator. So now if we look at number 16. Number 16, we have x squared minus 4 over 16x minus x to the 4th. Okay, let's see what we can do here. Let's see. I can pull out a negative x down here and now leave x cubed minus 16 over, then I can factor up here x plus 2 and x minus 2. But realize none of this is going to help out. Nothing's going to simplify. So what we look at is what is the degree of the numerator? That's 2. The degree of the denominator is 4. And the numerator is less than the denominator. The degree of the numerator is less than the degree of the denominator. So what would the asymptote would be? Y equals 0. It's not an oblique asymptote. This is a horizontal asymptote. So I guess to answer the question specifically, it says the oblique asymptote, we would say no oblique asymptote. And finally, number 17 is a real life sort of situation, and it is somewhat telling. We are injecting a drug, and the concentration is monitored. And the concentration, which is given by C of t hours after it's being modeled, and it asks what is the horizontal asymptote. Well, the horizontal asymptote, we realize, okay, this is what, 5t over 3t squared plus 2. The numerator, the degree of the numerator is 1, the degree of the denominator is 2, and since the degree of the numerator is less than the degree of the denominator, the asymptote is y equals 0. But here's what's really telling. It says, describe what this means in practical terms. Well, if we think about it, that means the concentration of the drug is going to get closer and closer to 0, but never hit it. Which, what does it mean in practical terms? The drug never leaves the system. It will never, ever leave your system entirely.